Greetings, ladies and gentlemen. I'm here to talk about the definition of cache, its structure, and the mechanism of storing binary data in cache. So what is cache? A cache is a high-speed data storage layer that stores frequently accessed video frames or segments. This allows the video player to quickly retrieve and play back these frames or segments without having to access the underlying storage medium. In April 1965, British computer scientist Maurice Wilkes introduced memory caching. Initially gave it a name that would no longer be politically correct: slave memory. The structure of cache memory is hierarchical, meaning that it is organized into multiple levels. In modern computer systems, there are typically 3 levels of cache. Level 1 cache. Level 1 cache is the smallest and fastest cache level located directly on the processor chip or very close to it. It is relatively small in size, usually ranging from 8 kilobytes to 128 kilobytes. Purpose: Level 1 cache stores instructions and data that are currently being processed by the CPU core. It operates at the same speed as the CPU, providing extremely fast access to the processor. L2 cache. L2 cache is larger than L1 cache and is located outside the CPU core, but still on the same processor chip in most cases, typically ranging from 128 kbps to 512 kb or even more. The purpose is L2 cache stores data and instructions that are frequently accessed but not actively used by the CPU core. Multiple cores on a processor often share the same L2 cache. It is slower than L1 cache, but faster than accessing data from main memory. L3 cache is the largest among the 3 levels and is shared by all cores on a processor. It is usually located on the processor die, but outside individual cores, typically ranging from a few megabytes to tens of megabytes. L3 cache serves as a large pool of memory that can be accessed by all CPU cores. It stores data that is shared among different cores and applications running on the processor. While L3 cache is slower than L1 and L2 caches, it is still significantly faster than accessing data from main memory. This mechanism is essential for optimizing a computer's speed and efficiency. The storage of binary data in cache involves several key principles. First, cache memory is organized into lines or blocks, each with a specific size, often 64 bytes or more. These lines are indexed for rapid retrieval based on memory addresses. When binary data is accessed, the CPU checks if the desired data resides in the cache. This is achieved through a process known as caching algorithms. One common approach is the least recently used LRU algorithm, which evicts the least recently accessed data when new data needs to be stored in the cache. The binary data is stored in cache based on its address, and it is essential for the cache to be coherent with the main memory, meaning that updates must be synchronized to avoid data inconsistencies. In conclusion, the mechanism of storing binary data in cache is crucial for optimizing computer performance. By managing frequently used data in cache memory through organized blocks and efficient algorithms, computers can minimize the time spent waiting for data to be retrieved from slower main memory, resulting in faster and more responsive systems.